It all started out with a dream. When I was 3 years old, I remember my grandmother holding me at this very same spot. It was the sunroom at the home of Ruth and George B. Wells. I had many dreams over the years about a hidden staircase going up to a secret room, another about a treehouse, and yet another about a grand staircase going up to the third floor to which children were not allowed. For a long time, I wanted to see if there was any reality to these dreams. This is another photo of Ruth and George's house in Southbridge. In the center of the room is the sunroom. 4 years ago, I was visiting an old classmate of mine, Tim McNally of Pomfret, Connecticut, and during our conversation, he asked me why I was there. What's the purpose of my visit? I told him about my dreams and desire to see the Wells house again, and he said, I know the guy who's rebuilding it. Do you want to see it? Yeah, of course I do. The answer was obvious, and after about a 20-minute drive, we arrived at what he had called the Wells Mansion. Well, I remarked to Tim that there must be some mistake. This was not the home of Ruth and George Wells. Tim's response was that this was the home of John Wells, George's first cousin. I'd never heard of him, but as I found out, they lived less than half a mile from each other. Tim and the contractor gave me a tour of the house, but there was nothing to see except 4 things: a belt-driven workbench, his radio room, over 1,000 filing cards with notes that John wrote while on the radio, and a radio telephone phone patch. That's the workbench in the top left. The radio room was pretty much empty, but also nearby were that drawer full of filing cards, 3.5 by 5-inch filing cards, about 1,000 of them. And the phone patch. I'll talk about the phone patch pretty soon. So, who was John Wells? Well, John Morse Wells was born January 4, 1903 in Southbridge, Mass. He was the son of J. Cheney and Florence Morse Wells. He attended the Fay School in Southborough, Mass, and St. Paul's School in Concord, Mass. He received a bachelor's degree from Harvard University, where he was president of the Wireless Club. He served as a lieutenant in the Navy Reserve with the Atlantic Fleet from 1924 to 1941. He was an intrepid aviator, an excellent fly fisherman, and an avid worldwide amateur radio operator. In 1940, he joined Clifford A. Harvey to form the Harvey Wells Electronics Company, and his amateur call sign was W1ZD, so I call him the Wizard of Southbridge. This is the vault we were talking about. Doesn't everybody have one of these in their house? This is the vault. Everyone's home in the entire U.S. gets its AC power through a step-down transformer, usually placed on the street electric poles. Typically, the primary voltage to the transformer is around 13 to 15,000 volts. This goes into the step-down transformer that converts it to 120 to 40 volts, and then to your house's electrical system. John was not satisfied with normal house voltage, probably due to the power draw from his machinery and radio transmitters. There's also a loss of voltage in all wires. The longer the wires, the greater the loss. John convinced the power company to install underground lines with street level high voltage to this vault on the condition that he did not get a key. High voltage can kill you very quickly. Then there's this gentleman, Clifford Akers Harvey. He was born in Philadelphia on March 1, 1908. He graduated from MIT with honors in electrical engineering. Cliff founded the Harvey Radio Laboratories in Brookline, Mass. In 1933. Cliff got his ham license in the 20s, so early that he was allowed to choose his own call sign. He chose W for the East Coast, 1 for Massachusetts, and RF for radio frequency. Cliff built everything he used from scratch, developing the schematics for each transmitter and receiver himself, while he tuned up schedules with ham friends in England. He had a rhombic antenna in his back acreage pointed out in just the right direction, and I don't know much about them, but apparently they're very, very large. It was massive. Cliff had QSOs, which are radio conversations, with over 165 countries and more than 10,000 QSL cards. QSL card is something you receive from the other guy when you talk to him. He acknowledges. He had 10,000 of them. Cliff made all of his family televisions throughout his life from parts, nothing ever store-bought. He designed, constructed, and installed the first radio-controlled garage door openers for residential use in his home in Southbridge, but he never got a patent. And there's a picture of Cliff Harvey to the right. He designed and built a telephone system for the car that allowed him to call his wife, Betty, at their home and talk to her while driving back from work. He turned a ride-on lawnmower into a radio-controlled one and allowed a ham friend, Don Whitney, this guy's father, to try it out on the Harveys' back lawn. Don accidentally mowed down several newly planted apple trees, as well as some other silly things, but all to do with his love of electronics. Betty was not amused.
And that was a family joke forever.
I bet. A painful one.
Okay. The Harvey Wells Electronics Company. In 1933, as I mentioned, Clifford A. Harvey founded the Harvey Radio Laboratories in Brookline, Mass. He produced high frequency, VHF, and UHF radios. That's very high frequency, and UHF was ultra high. This equipment was used by hams and commercial enterprises. Meanwhile, John was the director of research at the American Optical Company, but wanted to go in a different direction. John had a great interest in radio, so in March 1940, he and Cliff formed a new company, the Harvey Wells Electronics Company. Cliff was the president, John was the treasurer. And then they moved into this large building in Southbridge. As Cliff's son, Clifford S. Harvey, said, it was a match made in heaven. Match made in heaven. Well, this was during World War II. During World War II, battles were won by the side that was first to spot enemy airplanes, ships, or submarines. To give the Allies an edge, British and American scientists developed radar technology to see for hundreds of miles, even at night. Radar could pick up incoming enemy aircraft at a range of 80 miles and played a crucial role in the Battle of Britain by giving air defenses early warning of German attacks. Harvey Wells was a pioneer in radar development and manufacturing, all during World War II. Harvey Wells made the first 50 radar units sent to combat zones for testing. The first 50. And its methods and designs were later used for mass production of this equipment. According to Dick Mahler, the vice president and general manager, Harvey Wells was one of the first to develop and produce radar equipment for the radiation laboratories at MIT. The Philco company also used the Harvey Wells designs for their long-range navigation equipment. Well, you've all seen walkie-talkies, they're everywhere, but they used to be big, bulky things. The battery pack, 2 guys, and batteries were heavy. According to the Southbridge Evening News on August 23rd, 1945, Dick Mahler said that half-pound radio telephones will be in general use in a year or two. They'll have a range of 2 miles, won't require licensing, and can be used to hook up to the phone company for people in rural areas. They didn't make them. They talked about them. They did, however, make aircraft radios, 2 different types. They made the AR-10A military receiver, and they made small aircraft radios, receivers and transmitters. They made aircraft radios, military receiver on the left, and small aircraft radios. Those 2 over there, to the right of the first TBS 50. Those are the radios, but those were used for small aircrafts. This is the big guy. It was manufactured in 1944. It was designed for military and commercial use. Tri-band performance, 195 to 415 kilohertz, which is pretty low frequency. 2.5 to 4.5 megahertz, and 4.5 to 8 megahertz. It operated on 14 preset frequencies. It was used for direction finding. It was very low weight at 21 pounds, and there was no sacrifice in rigidity or strength. It had 3 antenna choices, and all parts were accessible for inspection. High quality stuff they made. After the war, when World War II ended, the Harvey Wells Company diversified into the amateur radio business, and in 1947 built the TBS 50 transmitter. That one over there. No, to the left. Far left. Well, that's the C. That's the original one. The one to the right is either a C or a D. Subsequent models they made, which basically had minor differences. They also built power supplies, both AC and dynamometer versions. And they built a VFO that allowed the user to dial in a transmit frequency rather than have to change crystals, which was a vast improvement. I'll get to that in a minute. In 1954, they manufactured their first receiver, a 9-tube model called the R9A, and the Bandmaster receiver. The T90 transmitter was its match. This is that radio. That's a photograph I took of that radio. This was the first one. They went into production in 1947. It featured both AM, which is voice modulation, and continuous wave, which is also known as Morse code. It had an output of 50 watts and operated on most of the popular ham bands, 80 to 2 meters. And this was the predecessor for the other models, the TBS 50A, B, C, and D. I think the one to the right is a C. That were produced from 1948 to 49. They all required an external power supply, and they all had, the frequency was crystal controlled by inserting a specific crystal in the front port. All Harvey Wells equipment was built with the highest level of quality, and many have been maintained and still work today. The other models, the later models, the TBS 50 and the C and the D, mostly minor differences of frequency range and type of microphone. And they made a variety of power supplies so it could run on 12 volts, 6 volts, 120 volts. And they had different varieties to support all of their models, and made a crystal microphone. And they also provided schematics for all their power supplies so they could be repaired in the field. They made a new version of power supplies for their new radios, with their new tube radios. They ran on 120 volts. And again, they could you could run these radios on 6 or 12 volts. And they made auxiliary speakers so that you could use them in a mobile application. Crystals. All radios except the earliest spark gap transmitters used quartz crystals to set the transmitting and receiving operating frequencies. I don't know if you can read it, but you can actually read it from the actual one that I just now put into the radio. This radio would now operate on a frequency of 7173 kilohertz, or 7.17 megahertz. This crystal determined the transmit frequency of the radio. Harvey Wells was one of the first to initiate mass production of crystals. The government needed 24 million crystals, and the highest previous production rate was 50,000 a year. Dick Mahler said the government thought it was ridiculous when we planned to produce 1,000 a day. Within a month, we were turning out more than that. That's 260,000 a year. When other manufacturers first started mass production of crystals, there was a very high rejection rate. The average rejection rate at the other plants was 40 to 50%. At Harvey Wells, it was less than 3%. This is the VFO. There's an example of that over to the right of the table. All of the TBS series of transmitters required that a crystal inserted into the front panel be used to determine its operating frequency. Changing frequencies was very difficult until the VFO. The VFO made it very easy to use only 2 controls to operate on any frequency in the ham bands. A vast improvement. Then they made the T90 and TS90 transmitters, and they had a built-in VFO. You notice there's no crystal socket on the front of them because they didn't need it. You could just dial in the frequency you wanted to transmit on and you were done. A vast improvement. The T90 was the last transmitter that they ever made. It had a greater output of 90 watts on code, CW, and 75 watts phone. It was the first model with a built-in VFO and had temperature regulation, offered initial tuning at a low power, and required an external power supply, could be used as a mobile or a base station, and had many advanced features. And in that year, only cost $179. This year, $2,031. The R9 was the only ham receiver that Harvey Wells manufactured. It was considered a companion to the T90 transmitter. Also could be used as a mobile or base station. Operated on many bands, had 9 tubes. It was highly stable, had an integrated transmit and receive switch, in production until 1955. So that probably answers that question a little better. I don't know if anybody of you have ever heard of Heil Sound. He's a famous guy in the sound reinforcement business, also an avid ham radio operator. He took this picture last June, and this is from his email. I love my Harvey Wells twins. Took me a couple of years to achieve my dream station. Many would argue that a station built in 1955, 68 years ago, could be a dream, but I started my amateur radio life with the TBS 50D, which is still working. These 2 radios are all original. I have many present-day stations, but I have always been searching for the T90 and the R9A combination. Not only have I found a T90 and R9A, but I have ended up with 2 sets of twins. I've been using my dream station for the past month on our morning net, which is across Missouri, a couple of stations on the western edge of Illinois and 2 on the eastern edge of Kansas with Bob Heil. Probably the most important piece of equipment in any ham shack is to match antennas to the radio. They manufactured the Bandmaster Z-Match. It could be used with any transmitter, regardless of the manufacturer. It was designed to achieve high efficiency, operated on a range of 3.5 to 30 megahertz, had meters for tuning forward and reverse power, had an internal dummy load, and would tune any antenna with a 50 ohm load. Also came with a schematic and manual. Fairly simple device, but mandatory for all hams. The transatlantic cable, the first attempt was in the 1850s, and it was laid between Ireland and Newfoundland. The first actual communication was in 1858, but was of very poor quality. Sending a message took 16 hours to send 98 words. In other words, it took 2 minutes to send 1 character. The cable failed 3 weeks later. The second cable was laid in 1865, a third in 1866, and when deep sea cables broke, repairing them was a tedious job. You can imagine, it's got 2 miles down, how do you get to it, much less fix it? It wasn't until the 20th century that code speeds reached 120 words per minute. The cable was primarily used at first by the military and the government, not civilians. The rate for the first overseas call from New York to London in 1927 was $75. The first successful transatlantic telephone cable was not laid until 1956. Even then, the process of setting up a transatlantic call might take several hours. Eventually, the public was able to use the cable. You would call your local operator, who would transfer you to a traffic operator. That operator would in turn call the transatlantic operator and get in line for a circuit. You would then hang up but wait by the phone. At the other end of the line, the person you wanted to talk to would do the same thing. John had a solution, yet another way to do it. This is John's phone patch. John was a pioneer in many areas, and this was one of them. Sometime in the 1940s or 50s, he built this phone patch to connect a worldwide radio connection to a phone line in his house in Southbridge. Here's how it worked. John would get someone on the radio in Italy, for instance, and that person would say, "Hey, I have a cousin in Worcester." And John would say, "Hold on, I'll get them on the phone." He would then put the lever to the right, and the Italian person would talk and be heard by the Worcester cousin. By putting the switch in the other position, the Worcester person could now speak to the cousin in Italy over the radio. This was long before transatlantic private phone calls were functional and open to the public, long before the internet, and free. Speaking of filing cards, John Wells was a very active ham radio enthusiast. He made radio calls around the world and logged all of them. Here's one of more than 1,000. On January 4, 1947, at 5 p.m., you can read the card here, he contacted I1AY, who was in Milano, Italy. There's the date, January 4th. A frequency of 14.04 megahertz. This signal quality 588. That's in ham talk. That's pretty good. And he made remarks. He also recorded the client's radio power. The guy in Italy was cranking out 750 watts. I have these cards. This is, excuse me. This is one of the more easy ones to decipher, but he logged everything. NMR, magnetic resonance imaging, is a medical imaging technique used in radiology and uses strong magnetic fields to generate images of the anatomy. The Harvey Wells Company partnered with the Magnian Company to build the hardware. The precision magnet power supply, control panel, and the NMR precision Gauss meter are pictured here. Another pioneering effort. Here's the electromagnet. This is a monster. Notice that it's on a pallet. My guess is it weighs 1,000 pounds. I don't know. A biological sample would be placed between the two magnets, and the controllers in the previous slide would create a massive magnetic field. This field was then adjusted for power and frequency. The observed changes in reaction to the effects of these field variations were the first steps in building an image of the sample. It is water cooled, and it's still on sale at eBay. It is. But you must pick it up. The seller won't ship it. It's a nice addition to your collection if you have a spare room with a strong floor and don't mind wiping out half of your electronics. Now, a lot of people in this area know about this slide and what it is. 1955. Double the hurricanes. Connie and Diane, which struck within days of each other in August 1955. They exceeded the combined property damage of the flood of 1936 and the hurricane of 1938. Connie struck first on August 12th and 13th, sparing the state high winds but dropping up to 8 inches of rain, particularly saturating southwestern Connecticut. 5 days later, Diane arrived, pouring another 16 inches of rain. Diane alone caused an estimated $100 million in property damage and the loss of 70 lives. Flood levels in Southbridge to the right, and you'll see this for those who are going on the tour tomorrow. It's a nice little pond, the normal water level in Southbridge at the Quinnebog River at Old Sturbridge Village. And below is a sign showing the flood level on August 20th. And the bottom right is another picture I took from Dick Whitney's marvelous historical collection. In Southbridge, the Quinnebog River rose 19 feet. The Harvey Wells factory was 20 feet from the river. When I was last there a couple of years ago, there's a parking lot and some brush growing up by the river. And you look in the river and it's 3 feet wide, down there. And there's the Harvey Wells factory, 20 feet away. I'm figuring, what would that look like with 19 feet of water? Roaring, full of junk, dirt, rocks, trees. Phew. Well, after the storm, Cliff Harvey was devastated as he picked up handfuls of sand full of resistors, capacitors, coils, and other radio hardware. They didn't rebuild. John Wells and Cliff Harvey were inventors and builders. They had big dreams. They changed the world. When someone says it can't be done, it means that they can't do it. It doesn't mean you can't. The American architect Paul R. Williams said, "You can do anything." And it's not that you won't make mistakes, it's how you recover. Live your life as if you control your future. Build and create. To borrow a Star Trek phrase, boldly go where no man has gone before. And in conclusion, in 2023, the human life expectancy is about 79 years. Who will you be in 10 years? As you grow, you will learn how little you know. That's when you begin to learn how much there is to know. Thomas Jefferson said, all men are created equal, and they are endowed by their Creator with certain unalienable rights, that among these are life, liberty, and the pursuit of happiness. And if you follow your dreams, you will find happiness and become your own wizard. That's my part. Thank you. Thank you. Thank
Very
you.
nice, very nice.
Thank you.
Very nice.
And thanks to Dick Whitney and Jerry and Eric Wells and Franny Wells, who passed away last December, and some other people helped me with editing. I want to thank the ARRL for letting me give this presentation. Across the street is the main transmitter conglomeration that they do code practice transmitting. I talked to somebody, a friend of mine in Florida yesterday from there, that building. It was cool. And again, thanks to Eric, Dick, and the ARRL for allowing me to give this presentation.